Okay, it's the witching hour. It's my pleasure to introduce Hal Turley, W8 Hotel Charlie, and Greg Marco, W6 Italy Zulu Tango, two good friends who have been spending a lot of time in the Caribbean with George Walder, as the three of them have been testing something that they've called the radio in a box. You may have heard about this, and they're going to give you an in-depth overview of this new technology, which maybe 2-3 years from now, you're going to be hearing a lot about the success stories of using this in rare locations, because it's probably going to be a lot easier to get permission to do things. I'm going to let them fill you in on all the details and the secrets. I'm going to stop sharing. You guys can share your screens and your video, and make sure your mics are on. So Greg and Hal.
Okay, I'm trying to start my video here, John. It's not. It says the host has stopped it.
I don't remember doing that. I didn't.
I'm trying to start it, but it says that the host has stopped it. So I don't know what the status of that is.
How about this?
Okay. There
you go.
Let's try that.
Okay, so let's see.
You okay, Greg?
Yes, I'm good.
Okay. Take it away. Take it away, guys.
All right. Are we up and running?
The stage is yours.
Yep. Okay, John. All right, John. Well, thank you so much, and Rich as well. And we'll say good afternoon to everybody here. We're really honored to be asked to participate in this exciting technology that John's already alluded to, the radio in a box. It's the brainchild of one of the gentlemen. Hopefully he'll join us here, but it's what we have experienced in the last 6 months, 8 months with our trips down to the Bahamas. We're testing these ribs in a de-expedition environment to see how they'll play. Now, when we think of ribs, we'll go back to our childhoods, at least for me, and I envision our Fred Flintstone character and his ribs. Well, this isn't quite like that. Because as we all know, the basic requirement for working DX, it's a fairly simple equation. DXCC, if you're going to get it, the DX is going to have to be QRV, and the DXer is going to have to be QRV. And of course, said another way, which we typically say for the DXer, he must be in the chair. And in this case, our friend here, Al, is on a rock.
Hey, Al.
Yes, sir.
Your presentation is not showing.
How come?
I can't see it.
No, you need to share your screen.
You got to share your screen, Hal. I thought you did. I thought you were giving all your introductory comments before you were going to share your screen, but
no. Yeah. Well, I certainly appreciate.
Let's try that.
Yeah, let's try that again here. Sharing my screen.
And then just pick the window.
Find your PowerPoint.
In the view. Hang on one. Give me one.
Take your time. Take your time.
Okay. Are you seeing it now?
No.
Not yet.
Did you press share your screen?
The green button.
Green button.
At the starts, and then pick the application.
There we are. All right. So
just make that full screen.
There
Yeah,
you
There
go.
you
there
go. We're good to go.
you're good to go.
All right. Sorry about that, John.
Okay, no problem.
Okay. So there's our friend, Fred Flintstone. We'll maybe come back to him later. But again, for the DXer, he's going to have to be in the chair, or in this case, on a rock. And also in this case, we had from the BS7H, the 2007 operation, we operated from a rock here. And, you know, there was some controversy surrounding this. But regardless, this is one of those rare entities that has found its way into the DXCC's top 25 most wanted list, according to Club Log. In fact, it's moved up to number 4. If we take a look down this list, all 25 of these top 25 most wanted are restricted access DXCC entities. And so getting there is the trick. Out of the 25, 21 of them are islands, atolls, rocks, or reefs. And many of these are what have been classified as environmentally protected areas. And so for DXpeditioners to get access to these locations, getting the yes, the approval, is the challenge. And there's several hurdles, if you will, that we may have to overcome to get there from that parent entities, that DXCC's parent, either through their government. In some cases, it's their military. It could be an oversight environmental agency, or a combined group of agencies with environmental oversight, or private governing agency or body. And in some instances, a few of these, there's a combination to get that yes. Now, in the past 10 or 15 years, we've seen many of these island entities move up the list because the parent governments have designated them as protected areas or eco reserves. And as a result, it is extremely difficult to get access to operate amateur radio from there. In fact, from a recent denial on a DXpedition permit application, one of the responses was that the increased footprint required to accommodate the proposed amateur radio camp and the personnel would negatively impact the island's terrestrial habitat. And so if we go back to the 25 most wanted list, we look to see that 5 out of this 25 are actually U.S. possessions, where we would expect at least maybe a little bit of easier access, but obviously that has not been the case. Now, people don't want to, make a mistake or look stupid or mess up in reviewing these applications. So, the bottom line is it's easier for them to say no and hope you go away. And that's just the brunt end of it. If you've ever tried to access some of these locations, it's easier just to say no. And so the challenge becomes for the DXpeditioner and the DX program in general, to find a way to get through this barrier. And so the challenge is we're either going to have to go through it, under it, or over it, and come up with some kind of new way to, if you will, invent the wheel. And in this case, we're going to talk about a possible solution for DXpeditions to gain access to these no-go places. And with that, we'll turn it over to Greg, and Greg's going to introduce you to these two gentlemen. I think, Greg.
Here we go.
There you
Good
go.
afternoon, everyone. It's a pleasure to be here. In this photo, it looks like we're having some kind of video problem because the pictures are distorted. But we have on the left, we have George, AA7JV. He basically came up with the concept for the rib, and his colleague, Mike KN4EEI, who helps George on a number of different projects, including the rib project. So the development that's going on now is the result of sponsorship from the Northern California DX Foundation. We currently have 6 ribs under construction, and want to thank them for, here, I'll cut my video on here real quick. For some reason, I cannot start my video, so I'm just going to talk. Without their support, this project would not be a project. So the concept of the rib is really pretty straightforward. It consists of a radio, in this case, our Flex 6000 series radio, a solid state water cooled legal limit amplifier, control and cooling subsystems. This entire solution is enclosed in a waterproof, environmentally controlled enclosure. Operators stay on the island, radios and antennas are on, or excuse me, operators stay on the boat, radios and antennas are on the island. As a result, we have to have connectivity between the two. And for that, we have a 900 megahertz Ethernet bridge. The boat can be anywhere from as close to shore as possible or a couple of miles away. And once a day, 2 people would visit the island, top off generators and do maintenance, etc. So looking at the high level architecture of the rib, we've got a Honda 2000 watt generator, an auxiliary 5-gallon fuel tank, which gives us a total of about 6 gallons of fuel per generator. The rib itself, battery backup for some critical circuits, receive antennas, and transmit antenna, and a 900 megahertz link to the boat. So this is George and Mike. This was taken a year or so back. They're holding the rib, and below there are a couple of cases with connectors and cables and such and tools. But that's the extent of a single station less antenna. So this is the way we used to do it. And this picture is actually the inventory from the Beauvais DXpedition. So, yeah, can we somehow close the box that's blocking the slide? I don't have control over that. There's a ribbon across the top. Now it got bigger. Can you see what I'm talking about, Hal?
That's on Hal's end, I think.
Yeah, I think so. Okay, I'll continue while Hal works on that. But what we have here is, this is most of the inventory. This is not all of it. What's missing from this picture, to put it into context, is the tents and the flooring system for the tents are not pictured here. They were actually down in Argentina when this shot was taken. So this is really not all of the infrastructure that that was involved. Okay, and this is what that same amount of inventory, and this is for an 8-station DXpedition, looks like in a 40-foot cargo container. So it's packed about 3 foot deep on the floor. There's an thank you, Hal. There's an overhead rack with aluminum and antennas and such. So it's an awful lot of inventory and materials to mount an expedition of that scale. So what the rib brings to the table is a significant reduction of the on-island footprint. And what we have here is a complete station that is going to be set up on an island in the Bahamas. You've got your generator, fuel, cables, everything is here. In contrast to the previous slide, you can see how much of a reduction we've had in the equipment we actually have to ship and bring on board to the island. Here's 2 ribs, and these are set up on Wood Key in the Bahamas. It's about a 5.5 foot long case, weighs about 75 pounds, and everything is self-contained in these enclosures. On the 2 trips we've been on the last several months, we fired up 4 ribs simultaneously, and this last trip in March, we fired up 2 ribs. This is a picture of the cooling system, and I'll talk more about this when I go in and do a detailed block level presentation on the components that make up the system. So on this slide, it's kind of hard to see. There are two closed loop water cooling systems. One cools the interior of the enclosure, and the other cools the pallet on the solid state power amplifier. There's a controller in the middle in the sort of salmon colored box, and it provides control and monitoring for all the subsystems, including what's broken out in a separate box as a receive antenna controller. Want to touch base a little bit on the powering of the amplifier. If you've been on an expedition or operated a high power station off of a generator, you've experienced there's a severe amount of throttling that takes place on the generator when the transmitter goes from key up to key down. This is very inefficient. It burns a lot of fuel. In fact, tests we've run have shown that running a single 500 watt station, you're burning almost the highest fuel consumption that's spec'd by Honda on these generators. And so what this is an 85 farad capacitor bank. I think that's 85 million microfarads for your microfarad guys. And what it accomplishes is it significantly smooths the throttling of the generator, reducing wear and tear on the generator while also significantly improving fuel efficiency. So this is the inside of the rib, and we're going to go from from right to left. We have two power supplies, one to power the radio and one to power the amplifier. These are powered off of 240 volts from the Honda generator. We have the ultra cap bank for the PA. Again, that's to improve efficiency overall on the power side. Cooling fan is next. That's for the internal cooling of the rib. The water-cooled PA, which is designed by George Wallner and constructed by George. The Flex 6700 is underneath the enclosure, which holds the digital acquisition and control system. It's a commercial product from a company called Daisy Lab. And I believe it's the same control system that George actually uses on the magnet. And then next to that is Ethernet switch and PoE for the point-to-point radio. And you can see a little water reservoir and sort of an air column and some cooling lines. And excuse me, voice is a little hoarse. And this is what makes up the rib. One thing that concerned me when I got involved with this project is how is my perception of what was additional complexity going to impact overall reliability. And so I kind of threw this block diagram together. Unfortunately, it's not very clear. But if you were to take a Flex system on a DXpedition along with a Ethernet controlled amplifier, this solution only adds one additional IP controlled device per station. We've moved around the components of the solution, the station and all that. But what we've learned is that the system is extremely reliable. We really haven't had any major issues. We've had a few problems, which
We lost your audio, Greg.
Okay, bear with me. Yeah, I had a problem.
Take your time.
Can you hear me now?
Yep.
Okay. Had a momentary power hit and it kind of messed up my dock. So move on to the next slide. This is the user interface for the Daisy Lab DAC. It gives you all the monitoring parameters you need for the radio and the amplifier. One of George's antenna solutions incorporates a remote antenna mounted automatic antenna tuner. It controls that. It provides switching for the receive antennas. So everything you lose from having the radio remotely has been put onto this user interface. So from an operator perspective, you've got access to all the control, all the information that you need.
Hal, just a quick one. Turn your video off, Hal, while you're showing the slides. It may help. Just mute your, yeah. And then move your mouse to get that bar out of the way.
Somebody else got that bar out of the way. I don't know who did it. It wasn't me. Well, I got credit for it, but I don't know. I tried to move it.
Click on the PowerPoint, Hal.
All right.
That did not do it. Okay, let's go back to where we were. Okay, so this is a picture of the link between the boat and the island. It's a 900 megahertz link. We're using actually two types of radios, Ubiquiti M900s and a product from a company called Cambian, which is located in San Diego. Both solutions work very well. To deal with multipath and other fading anomalies, we're using space diversity. So we've got two high gain omnidirectional verticals on the boat and two Yagis on the island. And we found out that having some space diversity is absolutely paramount to having a reliable link. And these links on the last two trips have been pretty much rock solid. And we're going to continue to sort of look at how we can evolve this to make the performance even better. So this is a picture of George's boat, the Magnet. It went in the water last year. It doesn't look like it, but this is a purpose-built DXpedition boat. It is about 275 tons. It holds almost 30,000 gallons of fuel, 5,200 horsepower, and it has an extremely long range and good cruising. And it's a very stable platform. It's an amazing feat of engineering. Okay, here we are on top of the Magnet. It looks like I just crawled up on top and maybe I had to take a break there for a second. But George and Mike are working on the two Omni antennas on the boat side of the 900 megahertz link. So let's talk about the value proposition. Minimal impact, rapid deployment, and we've gotten to a point in the evolution of the solution. When I talk about the solution, I'm talking about ribs, antennas, power, everything soup to nuts. It's now how quickly can we put up the antennas? We have no people on the island. We have no time wasted setting up tents or any other sort of creature comfort infrastructure. We're not moving operators back and forth. Operator endurance is enhanced. We're not getting any younger. It's not getting any easier. Significant simplification of the logistics and transportation. If you think about the impact of the rib and from a concept of a DXpedition to the end and getting all your materials back, it impacts virtually every step of the adventure. And it's significant. And the lower fuel consumption it plays very well because it's all part of, a lower impact, greener footprint. And that message hopefully will resonate well. So again, lower cost, minimum impact, and more efficient. And we have more time to make contacts for y'all. So here we are in George's shop. You know what? When I first went down this last year, I stepped in George's shop and I go, this is kind of probably a 21st century version of what Nikola Tesla's workshop looked like. Well equipped, plenty of parts, all sorts of things in the shop, things that George's had invented, for his commercial ventures. It's just pretty, just everything he has in there is kind of amazing. So this is sort of my first exposure to the rib. George is taking me through the configuration of the DAC, and I'm trying to soak a lot of information up in a very short period of time. This is finishing up this rib. Our trip in November was impacted by a number of delays and things such as hurricanes that put us a little bit behind schedule. So we were working right up to the 23rd hour before we boarded Magnet and headed to the Bahamas. Packing some of the equipment. It was all packed in totes and Pelican cases, and we're just sort of sorting through and making sure that we're not forgetting anything. Underneath that tarp is a very high performance four-wheel drive electric vehicle that Mike built from the ground up. That is pretty impressive. So here we are leaving Miami. Heading out to the channels. We also had some non-hands on the boat. See you in 3 weeks, Miami. So we're underway to the Bahamas, and once we get out of the harbor and everything gets settled in, I'll get to your question in a little bit, Rich. We set up the ribs on the boat as they would be configured when we arrive at our destination, just make sure that all the systems are playing well. The only thing that is not part of this mock-up and test is the link radio. For me, this was a significant learning experience. I kind of was tasked with doing all of the network stuff, and so getting my head wrapped around that and getting it documented so I could understand it was all part of this process. Again, this is the stateroom on George's boat. The boat has a 44-foot beam, and this room runs basically from side to side with the exception of some space for walkways, and just kind of making sure everything's cooked up, working through any issues that come up. Making sure the maestros are talking to all the radios. And here we are approaching Wood Key. George knows the Bahamian waters very well. If those of you who've been there know that most of the Bahamas are in very shallow water. Magnet only has a 6-foot draft, so there are channels, and George knows where they are, even if they're not mapped. And here is on the left we have Mike. He's the captain of the boat, and in the hat stowing the line is Mike Canford, the guy. And they're taking a load of stuff to the island. Everything is water, evacuated water as possible. Fresh water on the island to wash our hands. Waterproof things goes a long way. No, it wasn't fun at all either. So here we are at Wood Key, getting ready to beach. On the first trip, we had this complement of antennas, which would be very similar to what you would take on a large-scale de-expedition. We quickly realized that it was taking us no time at all to set up the ribs, and we were waiting for the antennas. We're actually not waiting for the antennas, but the amount of time put into antenna erection was significant compared to the amount of time it took to get us the rigs deployed. So on our second trip, we reduced our antenna footprint significantly. We actually had one rib and one antenna up and running 60 minutes after leaving the boat, not getting out of the tender, but actually leaving Magnet. So we'd gone into this with a much smaller footprint, and our focus now is looking at the antenna systems. What can we do to maintain a reasonable level of performance, yet have lower profile antennas that can be erected very quickly. It's all about hitting the beach and the amount of time it takes us to get it on the air in a scaled manner and giving you guys contacts. Mike is here working on the support for the 160 meter antennas. Spider poles are used extensively. Getting the guys out. We've got the antennas, the 160 antenna. This is the 80 antenna, I think, because I can see the 15 meter SVDA in the background. But the verticals all sit in the water at high tide. There is some frequency shift as the tide cycles from high tide to low tide. And that speaks to the importance of having, especially for the low bands, excuse me, an antenna mounted remote antenna tuner that's automated so that we can keep up with the antenna tuners, with the antenna resonance as it changes due to tidal action. A tender's tied off. We put a mooring line in the water. We're tuning the antenna here. This is the receive array. It's actually in the middle of the island. It's a four-way array with a low noise preamp, pre-selector for the various bands. And I was kind of surprised that George could hear my station in the Bahamas on 160 at 3 o'clock in the afternoon. I guess I was pleased and surprised as well. So going through and working through some of the small details and issues that came up, and we've got some of the ribs have a local PC. This is the fuel generator station, if you will. And Rich, the reason we have to go over once a day for fuels, we can take as many days of fuel over as we're permitted, but we have a little bit over probably about 30 hours of runtime on the 6 gallons of fuel that this system provides. So somebody does need to go over there and just top off the tanks on a daily basis. This is a station set up a magnet. You can see Wood Key in the background. We're getting ready for CQ Worldwide here. Playing around before the contest, I'm guessing, because I think that's Hal in the background. Going over some of the station issues with Mike. Here we are during the contest. George is a top band specialist. He loves a top band, so he took 160 and 10. Hal had 15 and 40, or excuse me, 80 and 20, and I was on 15 and 40. We had real good propagation. We were pleased with the results of the contest and what we were able to achieve. Here we are after the contest. Everybody's pleased, tired. And here's our results. We finished number 9 in the world, number 3 in North America. And this is with just DXpedition antennas. We didn't have any big arrays, so we felt pretty good about competing with the big stations and what we realized. The ARRL 160 contest was a couple weekends later. We got on for that, and we finished first place DX, which isn't a surprise, being 70 miles from the US, but we had a lot of fun on this. We had actually moved the station from Magnet to Electra. This is George's other boat, the Electra. You've probably seen pictures of this. We moved all the gear on board, reset up the stations, fired up, and operated the second contest. So here's a video of the island. The drone is flying from east to west. And you can see as we come around the north end of the island, a massive sandbar that's there. And you could probably see the 160 meter antenna. And as we go around to the northwest corner of the island, we had vertical for 40, vertical for 80, and actually inverted L for 80, and SVDAs for 20 and 15. These SVDAs were wire supported by a single spider pole. And I think this configuration was first used by the Clipperton group back in the Pacific a couple decades ago, but it works real well. It just takes a bit of time to get everything set up. So in summary, we thought we were very successful with the testing. You have glitches. The efficiency of deploying on our second trip compared to our first trip increased significantly. Everybody knew what was needed. Everybody knew what their jobs were. Everybody knew what to do when and what direction to pull in. And once you get this done, once you've done this once, you can get very efficient at it, and it comes together very quickly. So operating results, we made about 7,500 Qs in CQ Worldwide, 1,300 in the 160 contest, about 4,200 in WPX. All in all, we made about 14,500 Qs. It was a lot of fun and looking forward to going back.
Okay, so the question, and is my audio on, Greg?
Yeah.
Okay, so the question then becomes, will this rib technology help in the future, help get the yes for these de-expeditions that are trying to get to the no-go entities? That's the that's the question. Will we be able to see a rib in use at a rare and protected DXCC entity? One place that comes to my mind is at Johnston. Perhaps this would be a good location for Johnston Island in the future, where the rib technology is used. Certainly, it would have worked out really well at Scarborough, again on the rock there, with a rib perched up there instead of this operator. But the way this is being perceived, if the DXCC program and DXing in particular is to thrive, we're going to have to continue to look at new ways, new technologies to reinvent that wheel, or as they say, think outside the box. But in this particular case with George and his rib technology, he's thinking inside the box, and he's developed quite a piece of technology here as a potential solution for getting to some of these remote locations that we otherwise may not stand a chance to access. Now, Greg kind of touched on this, and we're going to go back to our little Stone Age guy here, BC, I guess, back on Johnston. If we take a look there, we see that something is missing in this photo, and it's the antennas. And as I said, Greg touched on this. This was an antenna configuration that was used on Midway, I believe, the last Midway operation at K4M. And so, again, this is another hurdle that de-expeditioning is having to deal with. In addition to the operator footprint, from another denial, the agency that was reviewing the permit application used the antenna structures, the vertical structures, as a way to, they included that in the denial with this statement. We have determined that deployment of vertical structures would pose an inherent collision risk to the native seabird populations on the atoll. These birds have inhabited the open areas for thousands of years and would not be accustomed to avoiding newly erected radio operator tents, guy wires, and antennas. And so it's not just the operator footprint issue that the rib addresses, but there's a second leg of what I term a three-legged stool here that we're going to have to take a look at. And the second leg deals with the antennas. And so we've got our operator. If he's going to get on this island, he's going to have to sit on a three-legged stool. Well, as Greg mentioned, our purpose, one of our purposes for going back down in March, was to operate in the CQ WPX contest, where we did have another pretty good showing, and are currently in the multi-2 category at fourth place last time I looked. But in addition to the contest, George wanted to test the step IR, the big IR, with rib control, and see how that would work out. And in addition to that, we wanted to do some testing with antenna that DX Engineering has, the TW antenna, which I'll talk a little bit about. So we're looking at antennas, what we can do to minimize the aerial footprint, if you will, in that regard. And here's the guys who were out working on the step IR. They had incorporated the controller into the rib, and we were successful in tuning the step IR remotely from the boat using the step IR controller system. And here you see it integrated into this particular rib. With the TW antenna, I'm sure John remembers this from our K9W operation a few years ago out on Wake. We had concluded the operation, and we were about 150 or so cues short of cracking 100,000 cues. And Joe Pater had this little TW antenna, and we just kind of laughed about it when he pulled it out. We'd already taken down our step IRs, and Joe set this up on the beach, and I joked with him. I said, "Well, are you going to hang your clothes up on this or what?" But we were really kind of impressed with the performance of it. And now with the advent and the onset of FT8 weak signal mode, I wanted to see just what this antenna would do. And so I borrowed it from Joe Pater and took it down to Miami with us, and we took it out on the Wood Key and did some testing with it. It's a basically an omnidirectional center-fed vertical dipole. It stands 8.5 feet tall. There's 4 pieces to this, and it can be put together in literally in 5 minutes. I had this thing up and with the coax hook to it, and so it does not handle legal limit on power, but I wanted to test this and see what we could do with it. And so paired it with one of the ribs and operated at only 100 watts, only FT8 mode. And over the course of 5 days, I did some sporadic operating with it, and was about 14.5 hours total operating time under not really great solar conditions. So during that time, just testing it at 367 QSOs, I tested it on 20 and 30 meters, and you can see the breakdown there. But during that time, I logged 22 zones, 49 DXCC entities on those 2 bands, and worked some pretty good DX, as you see there, with the longest QSO going to VK6R out in Perth with 11,300 miles. And so looking at the log entered into Levin Central, which is quite a neat little tool, you enter that in there and generate this map. This is what the 367 Qs using the TW antenna look like from the log. And then with also using PSK Reporter, we downloaded the stations that heard us. These were on 20 meters. When I was on 20 meters, these are the stations around the world that copied C6AGU on 20 meters. These were the stations that copied C6AGU when I was on 30 meters. Again, 100 watts. And so this is a combined of all the stations that heard us on both bands during the times that we were on the air operating FT8 mode with the TW antenna. And so with concluding from that, this thing does, or this type of antenna does offer rapid deployment for portable operation. Again, it can be put up very quickly. Would have liked to maybe tested it on some of the other bands and other modes, but it certainly offers an opportunity for being an effective alternative to some of these antennas that may be perceived as more intrusive. You don't have to put guy wires on this. You don't have to dig holes. You don't have to drive stakes in the ground. You set it up, and it's a non-invasive antenna. So again, I want to personally thank the Northern California DX Foundation for sponsoring the RIB program. Their involvement in this is coming at a critical time, at least in my mind. And so I applaud them for their support of this. And then with that, I also want to thank the good folks here for inviting us, and we'll turn it over for questions and comments if that's okay.
Oh, it's definitely okay.
Okay. All right.
Thank you. Interesting comments, already a couple. Let's see. We're okay time-wise. So there are a couple of folks that want to know what happens when you go to the deep south, like to the Arctic. Questions is, how is the cooling system going to work in an Arctic environment?
Really well.
You may have to explain that.
If the enclosure got too cold, you could always turn off the cooling, or a simple thermostat and a solenoid valve system could be implemented. That would be a small incremental effort to make that work.
Okay. All right. What's the weight and dimensions of the RIB?
It weighs about 75 pounds. The length is about 60 inches, maybe a little longer.
Here's a question. Do you think you can deploy a RIB in a hostile environment, say Bouvet or Peter 1, entirely by helicopter with no boots on the ground?
We have talked about that in some detail, and the answer is yes. About having a RIB and an antenna system that automatically deployed. That level of mechanical complexity could be a challenge. Somebody's already built that, and it would be a matter of just repurposing some sort of automatic erection system to this solution. But it's been talked about.
I'm not sure I would call it
great length.
Yeah. Other questions? If any of you, let's see. A strange question from Bobby Burgess. Have you ever had a police authority take one of those ribs away from those islands before? Not sure what's behind that question.
The answer is no.
Okay. To the attendees, if you want to ask a question, raise your hand and I can open up your audio. You can ask them a question directly if you'd like to do that. Do you happen to know if George is going to be joining us? Oh, we have one. David Hodge has raised his hand. David?
Okay, can you hear me?
Yes, you're on the air.
Yeah, thank you. I was just curious about corrosion, saltwater environments, what plans you have to go through those boxes over time. I mean, after a couple of deployments, I wonder what they are experiencing.
Well, back to point in the presentation we were talking about is all the external connections are capped. We go to great measures to avoid salt infiltration from our hands. We wash our hands regularly when we're working on the ribs. There are going to be challenges with corrosion that you can't avoid it. You can't eliminate it. So the thought process is to minimize it and to understand it and to know what to do in the event that we do have an issue that is based on corrosion. We've experienced that sort of thing, and we've worked through it. There's been some thought that some of the things need to be replaced after every trip, like maybe the 900 megahertz antennas or the jumpers associated with that. But the methodology, the thought process, the ribs themselves, it's constantly evolving. This is not done cast in concrete. You know, there's a lot of thought, a lot of work, a lot of discussion going into how do we continually improve this to make it a more viable, more robust, and an easier solution to deploy.
Thank you.
Mark Aker is asking an interesting question. How do you support this going forward? That is, to get the expeditions to adopt this.
Well, that kind of goes back to how we got involved in this in the first place. I had traveled with George before on an expedition. We'd kept in touch over the years. You know, John, you were on Navassa with us.
Yeah.
And Hal and I were working on an expedition to Chesterfield when the pandemic broke out. And the thought process Hal and I were going through at the time is how to avoid the no. And you know, Hal elaborated on that in his presentation. I knew that George was working on the rib. We'd touch base, you know, periodically. And so I reached out to George. He'd been to Chesterfield before, let him know what our plans were, and wanted to talk to him about the rib. So that kind of kicked off our involvement in this, and we've fortunately been able to stay involved. And it was sort of the catalyst that got the Northern California DX Foundation involved. I don't know who kicked it off, but I know that Glenn Johnson was privy to our conversations with George. And very quickly, about September of last year, August last year, this thing kind of rolled up, and you know, NorCal stepped up to the table and provided the sponsorship that was needed to get this project off the ground. You know, some 8 months later, we're close to having 6 ribs built, and you know, we're real happy with where we are, and really looking forward to that first opportunity or that next opportunity.
Another question about condensation, or how do you manage condensation problems inside the rib in a highly humid environment?
You know, it's a good question, and it's actually something I haven't thought about because I have not noticed any condensation inside the ribs when I've opened them up after they've been operating for a period of time. But if it was an issue, probably desiccant. You know, there's a number of ways to deal with that.
All right, well, love to spend a little more time on it, but we've hit the witching hour at 3:55 or so. We'll say thank you very much for just a real thought-provoking thinking inside the box presentation. We are looking forward to hearing a lot more as time goes on.
Awesome.
I have a few
pleasure, John. Thank you very much.
Wonderful to have you guys with us. Say hi to George. And let's see. I'm going to take back the screen for a minute. Is that okay, Hal?
You're fine, buddy.
Nice to see you guys, and I love your beard. It looks great.
Thank you, John. Hope to see you soon, buddy.
Okay.
All right. Thank you, Rich. You guys take care.